Hello everyone. Hello, welcome back. So yeah, we are back again with the live session as I have promised yesterday. Yesterday's session was disrupt because of some network uh, issues. So we are back with the same topic. Okay. What I'll do today, first of all, we'll quickly see our the quiz session and then everything where we have left. Okay. So we have completed the data visualization. So now, today we'll just review everything from the very beginning, okay, and then we'll continue with the feature engineering and model training and all, okay. So yeah, so let's just start with our quiz session first. So I hope, uh, okay, few people have joined. So what we can do, we can just start the live session. So let's start by first question for. Okay, I can see the people. Okay. Now I'm using the same class file, okay, so that people will not get confused, okay. So we are on the same topic which we have seen yesterday, house prediction that was not completed. We have seen till the data visualization part, so that was the first part. Now we have come up with the second part, okay. So guys, the first question is on your screen. Can NumPy arrays store elements of different data types efficiently? Yes or no? Okay, as I can see, uh, one no in the chat. Okay, so let's see if few more people replies or not. Or let's do what? Let's go ahead. Okay. Um, because yeah. So rightly said, uh, no is the correct answer because NumPy arrays are homogeneous. Okay, so they are homogeneous in nature. It means that all the elements, okay, share the same data type. Okay, so if you have created a NumPy array, so if first element is an integer, so then rest of the elements needs to be integer. Otherwise, it will give you an error. Okay, so the answer is no. That is correct. Let's move to the next question. Okay, so the next question is on your screen. That is question number two. Is pandas primarily used for handling structured data like tables? Yes or no? Okay, I'll again repeat the question. Is pandas primarily used for handling structured data like tables? Yes or no? Okay, I can see one yes in the chat. Okay, so yes is the correct answer, guys. Okay, so guys, those who of you are watching and knows the answer, please try to reply because I put these quiz sessions in the starting of the live session because to make the session interactive, okay, so that you guys can ask questions, okay, that I have not understood. So I'll make you understand, okay. So that's why I'm taking this lives, so live sessions. So the main reason is that so that our whole session should be more engaging, okay. So that is please try to participate, okay, and if you don't know it's okay, just try to give the answers, okay, and then if you'll give an incorrect answer, so I'm there to correct you. So for question number two, rightly said, one person is saying yes, so yes is the correct answer, okay. So let's move to the next question, that is question number three, that is, can a pandas data frame have columns with different data types, yes or no? So now this is a very basic question. Okay. So we in all most of our live sessions we deal with data frame only. Okay. And we'll see multiple columns in a data frame. So now uh, that can be one of the easiest questions. Okay. We have had till now in our all the quiz sessions. So you guys can reply. Uh, so the question is, can a pandas data frame have columns with different data types? Yes or no? Yes. Yeah. So rightly said, yes is the correct answer for the question number three. I- All the columns can have different, uh, can be of different data types. So yeah, by that, let's move to the next question. That is question number four on your screen. Is NaN, okay, NaN in pandas treated as a missing value? Yes or no? Okay, those of you don't know, is NaN means not a number, okay? So not a number in pandas treated as a missing value? Yes or no? Okay, okay, okay. Couple of yeses I can see in the chat. Okay, so that's very good. So for question number four, yes is the right answer, guys. Okay, so those who have said yes, yes, it is correct. Okay, so by this we'll move to our next question. That is question number five on your screen. So you can see, uh, does scikit-learn provide tools for both regression and classification? Yes or no? So those of you don't know, scikit-learn is a library, okay, is a module already present in Python, okay, so which has some ML models. So your question is, so does this scikit-learn provide for regression and classification for both kinds of models? Does it store both kinds of models? Yes or no? Okay. So for one part, I've given you the answer that yes, scikit-learn is a proper library which have models in it. Okay. Now the next part is that does it have for both regression and classification? That you guys have to reply with. Okay. Okay, I can see one yes in the chat. Okay, so let's do what? Let's go ahead with yes. So for question number five, rightly said uh, that it is the correct answer. Scikit-learn have models, tools for both regression and classification. Okay, so let's move to our next question. That is question number 6 on your screen. That is feature scaling mandatory for machine learning algorithms? Yes or no? So I'll again repeat the question. Is feature scaling mandatory for all machine learning algorithms? Okay, okay, I can see uh, one person is confused. What is feature in scaling? Okay, he's asking what is feature scaling. See, uh, feature engineering means bringing all the input features to a similar numeric range. Okay, we have done this thing in one of our live session. I don't particularly remember which one of them, but mostly with regression, where we are using regression. Okay, so what we do now, I have explained this. Okay, see, I'll just repeat the same example which I have taken at that time only. If suppose we have two columns in our uh, data set, okay, let's say age and salary. Now age values, the values, okay, present in age ranges from 18 to 60, okay, and now the salary one ranges from 20,000 to 2 lakh, okay. So now you can see a drastic difference in the ranges, okay. Both columns have, mean, suppose based on experience, okay, based on experience maybe the salary will be increases, okay, but in if you see numerical wise, so age has a different ranges, okay, it is only about 18 to 60, whereas salary is from 20,000 to 2 lakh, okay. So it means what, that salary now will do what, salary has much larger values in comparison to age. Okay, but both have equal importance. Both have equal importance. So what will happen now? Salary here can dominate. Okay, salary here can dominate at the time of training the model. That we don't want, because here uh, no feature should dominate others. Okay, because of its magnitude, irrespective of uh, the the importance, it should not dominate, okay, any one feature, because of its magnitude. As you can see, the whole ranges change. No, age has only 18 to 60, where salary is 20,000 to 2 lakhs. So because of this magnitude, so much high magnitude is present in salary values, okay, in comparison to age, okay, so it should not dominate. So because of that, we use feature scaling. So what happens, what we do in feature scaling, we just make, means what we'll do here, we'll make the salary with some, we'll use some technique, and then we'll make it with a range which will be suitable for age also and salary also, okay, and the values will remain same, but we'll change the ranges, okay, according to the current range, okay. So that is feature scaling, and it is required for almost for most of the time. For linear regression it is used, okay, whenever you are using linear regression, logistic regression, um, clustering, k-means clustering. See, these are some of the machine learning models. uh, Before using them, we need to scale them if there are very big, means there are differences in their magnitude and their ranges, okay. So then you have to do it. One more thing, if you'll not do it, then what will happen? Then maybe some wrong decision boundaries can be created, the accuracy will be poor, okay. So these kind of things can happen. So that is one of the things, okay. So this is feature scaling, to scale in uh, according to, means to put it in a standardized form, okay, simple. You can use standardization, you can use normalization, and there are many techniques, okay, which you can use. So it's upon you or on your problem, okay. So that is feature scaling. I hope you have understood, okay. So by this, what we'll do, let's move to the next question. So for question number six, no one replied. Okay, I guess um, people will be not knowing. It's okay. So actually, the answer will be no. So the question was, is feature scaling mandatory for all machine learning algorithms? So actually, not for all, but for some of them, yes, it is mandatory. But some algorithms like decision tree, random forest, they don't require scaling. Okay, so no. Okay. Uh, let's move to the next question. That is, can matplotlib be used to create both 2D and 3D plots? Yes or no? Okay, I can see yes in the chat for question number seven. Okay, yeah. So question CS is the correct answer for question number seven. Matplotlib can be used to create both 3D and 2D plots. So yeah, yes is the right answer. So by this, we'll move to the next question. That will be question number eight on your screen. Uh, is Python slower than C++ for numerical computations without optimized libraries? Yes or no? Okay, guys, tell me, is Python slower than C++ for numerical computations without optimized libraries? So if you'll not use those optimized libraries, okay, which is created in Python, so then Python is slower than C++ for the numerical computations? Yes or no? Okay, I can see uh, only one yes in the chat. Okay, so I guess okay, he knows the answer, and the answer is correct also. Yes is the right answer. That yes, it is slower if you'll not use some optimized libraries like NumPy and all. So then it will be slower. Okay, so yeah. Now the next question on your screen: does train test split function randomly split data by default? Yes or no? Okay, so I'll again repeat the question. Does trains test split randomly split data by default? Yes or no? Okay, Tamanna Patel, yes. Perfect, not yes. Yeah. So for question number nine, yes is the right answer. Okay. So by this, we have come to the last question of our quiz session. Okay, our quiz session part. That is question number 10 on your screen. The question is, can a Jupyter notebook run Python code cell by cell instead of sequentially from top to bottom? Yes or no? Okay, guys, now for giving this answer, I guess you guys should not take any time and just quickly reply it because all the time we are using Jupyter notebook only. Okay. When I started, uh, when I started our live session, then means when I just started taking live sessions. Initially I was creating videos for my, okay, for my channel, short videos of 5-10 minutes, taking one topic in Python and explaining that topic with practical examples, okay, and recording them and then uploading them. Then I thought to just directly go reach out to people, okay, so that to make it more engaging, okay, because uploading videos, I feel at that time that it was good, but I was getting, people were supporting me at that time also, but I feel that at that time that I'm not reaching the mass at that time. Okay, so because of that, then I decided to take the live sessions. Okay, I can see three yes in the chat for question number 10. Yeah, yeah, obviously yes is the correct answer. So when I started taking the live session, no, then I have uh, then I have in the first, I guess, first or second live session only, I have explained you why I'm using Jupyter Notebook, why Jupyter Notebook is better in, means everything, means every editor is good in respective of their uses, in respective of their use cases. But why Jupyter Notebook was good, because of this, one of the best feature is that it provides us cells. Okay, now there could be multiple resources, you can use Google Colab also, but Jupyter Notebook, because it is quite friendly, user friendly also, okay, simple functions, everything is simple, okay, yet I guess the best. Okay, yeah, so for question number 10, yes is the right answer. Okay, and I guess I have created one video on my channel also, uh, to show magic commands of Jupyter Notebook. Okay, so there are many things. Initially, when I have started, then I was not knowing this markdown thing, that what it will do, what is this raw. I just know about the code, but then I got to know that okay, there is markdown also, that if I have to write something, okay, so I can write it. If I have to make it a heading, then I mean these are the features which are available. So initially I was not knowing, but because of using it, okay, I just get to know about this. Okay, so guys, okay, I shared a story. By this, guys, uh, now this was the last question for our quiz session. So by this, we are ending our quiz session. Now we'll continue again where we left in the last live session. Okay, so in the last live session, I have not completed the topic, which was house prediction, because of some network problems. Okay, suddenly, so I just thought not to continue because the quality will be not maintained. So because of that, I stopped that time only. But as you can see, these were the things which we have seen. Means still data visualization, we have derived some of the data. Okay, now what we need to do, uh, now what I'll basically do, I'll start from the very basics of the last live session, okay, and one by one I'll be explaining everything, each and means each topic one by one, okay, so that what will happen, uh, means it will be easy for us, those who have joined today only, so they will also have an idea that what we have done in the last live session, okay, so okay, it will be good, it will be good for each and every one, okay, so because those who have joined today, they will feel like, okay, what is this or what is happening, okay, like that. So I don't want any confusion for any one of you, so please guys give me more 10 minutes, okay, and after that we'll start. So see, uh, so first of all, uh, in the last live session, guys, we have, let's have a revision, okay, let's just brief everything in short. So that will be a revision for all us also, and for new people it will be an, they will get an idea that what we are trying to do at that time, okay. So so in this cell was the starting, okay, so this here we have done all the setups. Setups means we have imported all the libraries, okay, so As you can see, we have imported pandas, numpy, matplotlib.pyplot, pandas for data handling, numpy for numerical computations, matplotlib.pyplot and c1 for data visualization. And warning is one of the libraries which I have used because in some of the commands you get a warning message, okay, because they are descripted. So what happens? They say that the interpret means they say that uh, they give an warning that use some different way, okay, but they are applicable till now. So because of that, I don't want that kind of thing. People get confused. People assume that that is an error, okay. So that's why I've used warning, and I have just used the filter warning function to ignore those warning, okay. Then come to the next cell. We have simply read the CSV file which we have. So the CSV file was for, uh, as you can see, the name Bangalore House Prices, okay, and it was in CSV format. So that's why we have used this function. Then we have used df.head to get a brief or get a look or top five rows of our uh, data set. So our data set was initially having 9 rows, 9 columns, and 13,320 rows. Okay, so 9 columns and 13,320 rows, where the values were, the first was area type, then availability, location, size, society, total square feet, how many bathrooms, how many balconies, and price. So these were the columns, okay, and price was the targeted, okay, price was the targeted value, means targeted variable or targeted column, you can say, okay, and rest of the other eight columns were the features. So based on this eight, based on these eight values, the eight columns, the targeted variable means the price was to be predicted or was to be evaluated. Okay, not predicted we can say, because prediction we will do now. Uh, Evaluation. The evaluation will be was done for this price. Okay, then we take check the shape, okay, shape of our data frame. Now because we have loaded the data set as a data frame in pandas, so now we are working with df is here data frame. So data frame dot shape gives us the shape that 13,320 rows and 9 columns are there, including the targeted variable, okay. Then we see the information. Now this function is used to check that what type of data type the columns are there, then what is the null count, okay. So this will give you a brief idea about how many columns of which data type is there, then if there are missing values in the columns or not, okay. Then we use the describe to see a statistical summary. So initially there was only three out of the 9 columns, only three of them were numerical values, so that's why we got only for these three. Then we give a check for the missing values, okay. So we perform a missing value analysis, where what we did, we just printed the exact value and the percentage both, okay. So here, as you can see in the society was the column where there was maximum number of missing count, and it was more than 40%, okay. Then balcony was for about 4.5 percentage, okay, 4.5 percentage. Then bathroom was where 73, where then size was there, and then location was with minimal one, and then rest of the columns were having no missing values, okay. So now this gives us an idea that these are the columns which have missing values and with the percentage. So with that, what we can derive that uh, whether to keep it or just directly drop it, okay. So with the data cleaning logic, the decision now, what we can do for the column society, we can just simply take a action, means we can directly drop it. Why? Because 40% values are missing, okay. So then no need that that society column will be, if we'll fill it also, then it will be not that much accurate, okay, because by 60% data we are filling the 40% data, that is not kind of good solution, okay. So dropping it is a good thing. So we'll in the next program, you'll see in the next cell, we'll drop the society. And for bath and balcony, as you can see, bath having 73 missing counts, which is approx half a percent, okay, not even 1%, half of 1%, that is half, okay. And then balcony having 4.5%, means 4.5% approx values were missing, okay. And then size and location were two values which have missing values, but it is negligible. Okay, so what we can do, we can just simply drop these columns because they are less than 1% only. Okay, so because bath and balcony after society, these two are the columns which have, okay, some missing values, so we'll handle only these two, and rest of the size and column will just drop the none values. Okay, so that will not affect our data set that much. Okay, so we can do that. So it's the same thing I'm doing it over here. First, I'm just we are just dropping the society column, means we are just removing it, and then we are filling the bath and balcony with the median. Okay, and then the rest of the none values, okay, that we are deleting it using drop and a. Then again we are checking the missing values, so now there will be no missing values. Obviously, the rest one of them we just removed it only. We just dropped them, so there is now no missing values is there. Okay, then what we did, I will notice at the time of info, when we are taking the info, so total square feet, okay, it is in object format. Okay, object data type. And if we just have a quick review at all the values, all the unique values present in total square feet, so you will see all of them are numeric values. Okay, so then what we need to do it, so now all these are numerical values, so basically we need to convert it. Okay, so we have given a check that yeah, it is an object value. So then we have created a function called as convert square feet. Okay, where we will convert the square feet, okay, into an integer type, into a float type. Okay, so now when you'll, and after converting it, because now there will be two, what do you say, two columns, one the converted one, and one the previous one, which is an object data type. So the previous one we just wanted to delete it, because why to keep it when we have extracted and converted into a numeric type. So that's why now you will see, now it has been the initial one we have deleted it, and the new one with new data type we have keep it. Okay, so with float 64. So now you can see total square feet is of float 64. Then we have again checked the value. Okay, now here we can see in the size, there is BHK, BHK, bedroom, and these kinds of things we can see over here. So what we tried to do here in the BHK column, we just wanted to extract all the BHKs, okay, from the size. Okay, so for that what we did, we just splitted the value. So we applied a lambda function here. Okay, now I am not going to explain lambda function because that I have already explained many a time. Okay, so please try to understand. But those one of you who don't know about the lambda function, please give me a hint in the comment so that I can explain it quickly. I can explain it quickly, okay, in just one or two lines. So yeah, and that I can do. So we have used the lambda function, okay, and we have extracted the first numerical value, and based on that we have created one more new column called as BHK. Okay, so we have extracted and created a new column BHK, and then the previous one, which was size, now we don't need it anymore because we have already extracted the value and we have created a BHK column. So we don't need the size now. So we just will drop it that column. So we are dropping the size column, and that's it. Then again we are checking. So now you will see total square feet, bath, price, and BHK is also in integer format. Okay. So now only three columns left: location, availability, and area type. Okay, which is in object format. So let's try to figure out that also. But before that, we just wanted to calculate the price per square feet, okay, which will be later on very important when we'll try to understand. Sorry about that. So, uh, yeah. So when we'll try to understand, uh, when you'll try to figure it out using data visualization, that what was the cost price per square feet based on the location, if this kinds of things will come, so then this will be important. So that's why we just calculated the price per square feet. So what was the initial price, in that we'll just multiply it with 1 lakh approx. Yeah, and okay, 10 lakhs approx, and then we just divided with the total square feet. Okay, so then we got a new column called as price per square feet. Okay, as we can see, based on the price we have calculated the price per square feet. Then what we did, now we started with the data visualization. So we just first look out at the price distribution. Okay, so where we can see that the data was totally right skewed. Okay, And then we just look out one more data, that is total square feet versus the price. Okay, so here we just saw that a clear positive correlation is there, okay, between the total square feet and the price. So based on the total square feet, the price is fixed. Okay, so there was a positive correlation. So increase in its total square feet can see the prices. Okay, and there were too many outlier values also, which we can see very far from all the values. Most of the value was ranging in this, and then the rest of, you can see the spread. Okay, so we can see that there are some outliers. Okay, okay. Then we saw the BHK versus the price. So here we saw that uh, the prices is increasing. If you'll see, if you'll notice, so increase with the BHK, the prices was also increasing. Okay, and there is many overlapping prices also. Okay, and one more thing we can say, that here we can understand that location matters. Okay, location also one of the thing which matters here. Okay, so because of that, now what we did, we just tried to find out location wise price, okay, per square feet, and we have fetched the top 10 locations. Okay, out of, in our whole data set, we have tried to fetch out the top 10. So when we have done that, so as you can see, this code is fetching the top 10 locations, and then these particular codes are used for data visualization. So the first location was Grih Lakshmi layout. Okay, okay, you can see you here. So we can say that location is the strongest price driver. Okay, it means which fixes the price, and that is a common thing which we can see in our day-to-day life also. If one of you who deals in real estate, or now real estate is one of the good investment people does. Okay, so you can see based on locations the prices are actually high and low. If you'll buy some flat or buildings or lands out of the city, okay, far from the city, so then it will cost you low price. Okay, then you can, in the same price, you can have more lands, more buildings, more flats. Okay, but if you try to find in the main locations of the city, then it will cost you more for the small flat only. So location matters. So location is the strongest price driver. Okay, then we again look out at the info to see what are the so again, three of the values are there, which is object. Now the data visualization, we are done with that. Only that, see, you can have your own. Okay, but with my understanding, I just have these many questions, so I just get the answers of these questions. Okay, now the next thing is to predict the value. So to predict the value, we will use some models where we can use logistic regression, we can use XGBoost and all. Okay, so if you have to use that kinds of models, so that models requires numerical values. Whenever you have to train, you have to make sure that the values are numerical. Okay, so when you have to predict the price kind of thing, when you have to predict numeric values, so then there was three columns left: location, availability, and area type. So on the availability, we have seen that what kind of values it have. Okay, and then we have stopped the live session at that time, so now we'll start after that. Okay, so let's see that. So let's look at that. So now let's just do what? Let's just convert the availability So for that, what I can do, I can create one function, okay, availability to binary x, okay. Here we can give a condition that if x dot lower in ready to move or immediate positions, okay, in our list, if we are finding these two things, so return 1, otherwise return 0, okay. Then we'll come out of the function, then we'll apply this function over here, and that's it. Let's execute this, successfully executed, okay. And let's, so now you'll see availability, now it has been changed to integer format, okay, because if we are getting these two values, so then return 1, otherwise if any date and any other thing we are getting, so then 0, okay. So we have changed it to numerical value, okay. So now all the values are between int, as you can see, int 64, int has converted to a numerical value. So now two of them are left, one is location, one is the area type. So now let's handle area type. First of all, let's just verify first how many types of value counts are there in area type, okay. So when we check the value count for the area type column, so then what we get super built up area, plot area, carpet area. So there are approx 4 different values, and with the value count also, that this value is approx this many times, and then that this, okay. So what we'll do, we'll just use one function which is get dummies, okay. Now what is the use of this function? This function is used to basically first of all understand the problem, okay, why we need it, why we need this function, then it will be clear why this function is used. So machine learning models, as I've already said, that they cannot work with the text like this, that super built up area, plot area, carpet area. That means that model will not understand that what is super built up area. We can understand that these things, but the model will not. So we have to make the model understand that what is the importance of this, okay, because model only understand numbers. So this get dummies basically converts the categorical text like this, okay, um, into multiple of 0 1, okay, columns. If you, okay, first let's just do it and then I'll show you, then it will be easy for you guys to understand. So pd.getDummies columns, let's mention the area type, okay. Basically it will make all the values, okay, all the category of the area type as a separate uh, values, and in that it will keep it as 1 or 0 format, okay. So if some values which were having super built up area, so for that particular variable it will be having 1, okay. And where super built up area is not, some other is there, so whether in that place in the super built up area variable, it will be 0. Okay, so we'll replace with numerical values 1 and 0. Okay, so then it will be a numerical thing. Okay, so that is the thing which we are in simple, that is what we are going to do. Okay, so now as you can see over here, what earlier there was 9 columns, now it has been 11 columns. How? So one of them have been increased. How it has been increased? As you can see, when we have used the get dummies, so it has created area type carpet. Okay, so area type is the column name, and then carpet, it has taken one more carpet. Okay, in that carpet, uh, now it is of Boolean type. Already I have said it will store it in 0 1 format. One means if particular in that column, if one row having plot area or carpet area, okay, so that will be one for means it is yes. One means yes here and 0 means no. Okay, so we have just separated all the categories as a separate column. Simple. In simple, understand that. Okay, so yeah, that is there. Okay, let's move forward. Then what we'll do, we have seen when we were visualizing the which one? Let me show you the scatter plot. Okay, so there were many outliers as you can see here. So now we'll try to remove these outlier. Okay, so let's do that. So from total square feet, okay, we'll try to remove all those things. So using uh, quartile 1 and quartile 3. Okay, so let's try to do that. Okay, I'll say that this could be one of the things which could be optional because sometimes the outliers are important too. It's not always necessary that you will remove it. Okay, so yeah, but it causes a variance, okay, in our data, so that we don't want. So then you can remove it also. Then next, what we need to do, then here we'll do basically df price per square feet greater than equals to 3000 and price per square feet if it is less than equals to 20,000. Okay, that's it. Let's run this. So basically what we tried to do here we just first of all filter based on the area per bhk. Okay, so this particular line calculates the square feet. Okay, the square feet per bedroom. So it will keep only the rows where the area per BHK is greater than equal to 300 square feet. Okay. Why we have taken 300 square feet? Because a bedroom smaller than 300 square feet is usually a data error or wrong entry. Okay, that it will be very, okay, means impossible, or it will be very poor quality. So that's why uh, greater than that will be taken, less than that will not considered. Okay, because that will be a very poor quality to give to our users. So that is one thing. Then what we are doing, then we are filtering based on the price per square feet. Okay, so here you can see we have used total square feet and BHK. Here we are using the price square feet per square. Okay, where we have put a range here that below 3000 is likely to be incorrect. Okay, or some it could be because the data set is for, as you've seen, Bangalore. Okay, so then it could be a rural anomaly, means some value which is far from the city. Okay, so that we don't want. And then above 20,000, uh, why we are not taking? Because above 20,000 can be a outlier, can be a luxurious flat. Okay, a luxurious flat. So that can be treated as an outlier. Okay, because that will be less in number. So that we don't want to take. So because of that, we have keep the range 3000 to 20,000. Okay. So I hope you've understood. Now, most of you can say that, sir, you said that outliers are optional. Sometimes they are important to keep, sometimes you can remove it. So why here we need to remove it? Okay. So because see, if you'll not filter it, so model will do what? Will train the model. So model will learn from noises. Okay. Because there are multiple noises. As you can see, you see here there are multiple noises, means they are overlapping. Okay, they are overlapping, so it means there are many. So then we need to remove it. If there were few, then we should try to keep it. And by that, if the model will learn from noise, so it will predict, the prediction will become unstable. The accuracy will look, uh, the accuracy will be good, but the real world performance will be, means that will be not achievable, that will be not good, basically a fail. So that we don't want. When we'll filter it, after filtering, we'll have a cleaner patterns, we will have better generalization, and most important, we will have a most trustworthy prediction. Okay, so the chances of the predictions which we have made, that will be accurate with the real world data. So that's why. uh, Wait a second, guys, let me just have some water. Just 1 minute, guys, 1 minute. Okay, yeah. So, um, so this is one of the things which is called as outlier removal that we have successfully performed. Now, what we need to do the next is, the next step will be, so we have removed the outliers. Now we have only, as you can see, only one object value, that is location. Okay, so let's deal with location and let's change it to some numerical value. Okay, so let's do that. So first of all, uh, let's first do what? Df locations. Okay, I made a spelling mistake. Yeah, yes. So, okay. So then what we can do, df dot group by, dot values sending equals to false. We want the top ones. Dot head 10. Okay. So we have the top 10. Chandrapura. According to the price of square feet, the top 10 locations are Chandrapura, Sarajpur, and these are the values along with their values also. Okay. So these are the top 10. What we'll do, we'll basically reduce the location cardinality. Okay. So let me write the code for that. So first of all, we have to again, uh, we want the location counts. Okay. So for that, we'll access the location. Uh, this particular line will do what? It will give us the count how many properties exist in each location. Okay, so this will give that. So counts. Then what we'll do? Then we'll try to find the rare locations. Okay, so locations which are very rare, because there would be some locations no which will be multiple times. Okay, so we will now try to find the locations which are rare in nature. So how we'll do that? So for finding the rare locations, it's very simple. um, we will just see that from out of these locations which we have, what are the locations which are less than 10 times. Okay, so less than 10 times means, yeah, it could be the rare locations. Okay, so, or if you want, we can do it in the next cell here. What I can do, okay, so these are the total values, the total count. Okay, now rare locations equals to location counts. From that, we'll try to fetch the location. So this particular lines means that we are finding the location that appear 10 times or fewer. Okay. So maximum is the 10 times and we have used less than, so fewer. So we'll store their name in rare locations. So there will be few samples models. Okay. So first of all, let me just run this cell. Okay. Successfully executed. Now the main important thing that what we are going to do, the main important thing, now we will replace the rare locations with other. So whatever the rare locations will be, we'll replace them with other. Okay. So first of all, let's fetch the location. Then in df dot location, okay, it will be inside the quotes. Then we'll apply a lambda function over here. Okay, that is place it with other if x in rare locations, else put it as the name, okay, itself. Let's run it. So if a property location is inside the rare location, means it is present inside the rare location, so it will be replaced with other. Or otherwise, if it is a common location, okay, so then it will be unchanged. It will means the whole location name will be entered. Why this step is important? See, the problem without this step is that there will be hundreds of unique locations. Okay, then when you'll use the get dummy now on location to just minimize it and to convert it into a numerical format, so what will happen? It will create too many columns that we don't want. We want that model should become, means that will make what, that will make the model slow and overfits, so that we don't want. Okay, so we want fewer categories so that the learning should be stronger. Okay, and there should be a better generalization. Okay, so generalization concept also we are using here. Now this particular technique is, okay, let me just write the technique name. Okay, it will be more easy for you guys. So this particular technique name is means the whole two, three cells. Okay, this is called as rare category grouping. Okay, or cardinality reductions. So, okay, so it can be known by these two ML concepts. Okay, so the rare category uh, grouping, this could be one of the name, or it could be known by the cardinality reduction also. Cardinality reduction 2. Okay, so we have successfully run this. Okay, now let's move forward. So now let's just quickly apply the get dummies so that it should be also converted into um, again in different columns so that all the columns could have bool values. So based on that we can train the data. So let me give the name location. Okay, and we'll drop the first property. So for that there will be drop the first equals to true, and that's it. Wait, oh, forgot the equal sign, and that's it. Yeah, so df.info. Now we'll try to learn. Now all the steps are done. So now we'll do what? We'll separate the targeted variable and the features. Okay. Now because we have to do what? We have to just convert it into what? We have to just train test split it. Okay. So because of that, we need to separate the target variable. So what we'll do? We'll take one x. Then in this x, we'll store all the features. Okay. So here we'll put all the columns, but irrespective of the price, means we'll exclude the price column because that is the targeted variable. So we'll exclude the price, and in y we'll just store price only. So this will be for testing. That is done. Now let's do what? Let's uh, see that if our data set is having any object value or not. So primarily this should give us a empty string. If it will give an empty string, then it's fine. If it is not, then again we have to fetch it. Okay. Uh, Only the spelling mistakes. Yeah. So index, as you can see, there is it is empty. So it means there is means on our x there is no object variable. So now we can move ahead with our train test and split. So we have to import that. So from sklearn dot model selection, first of all we need to import the train test and split. Okay. And let me tell you, we are going to use three models. First, linear regression, then random forest, and then one is called as XGBoost. Now, XGBoost is the advanced one, okay, of the linear regression, okay. So that's why we'll use XGBoost also, okay, and all these three models, and then uh, we'll calculate the we'll see the accuracy, means not accuracy, accuracy is not means some other features just like mean absolute error and mean square error R2 score. We'll see these three things to evaluate which one is better, and based on that we'll predict that. We'll go ahead and we'll do the predictions that which one is better. Okay, understood. So let's move forward. So now first start with the trend test split. So let's do that. So now this very simple. What we need to do, we need to just have four different objects. First is will be the X train, second will be the X text, then will be Y train, Y test. Okay, because train test split gives us four values. Okay, it returns four. That's why we need to store it, and then just use the function train test split and put those two separate data frames X and Y. One is the feature, data frame, one is the targeted with the targeted one, okay, and set the size of the test data, okay. So we'll take 80/20, so that is good, or you can take 70/30, it's upon you. So let's go with this, and you can change and you can check it also with whatever the test size you are getting best score, so that is good, okay. And let's fix the random state so that each time the same values on the same data set, it should be test and trained, okay. So yeah, that's it. Let's execute this. So successfully executed. Now let's just call the linear regression and just train the model, okay. So from sklearn dot linear, okay, let's create a object lr in which let's call the linear regression first, model, then let's fit it. So fit with xtrain and ytrain. Okay, so model has been trained. Let's call the random forest, okay. So in which sklearn random forest is present and assemble. So from sklearn dot ensemble import random forest regressor, because we have to predict a numerical value, that's we are using random forest regressor, okay. Let's set some estimators. Random state would be again the same on the same set. X train, Y train. Okay, this is also done. Now we need to call the XGBoost. Okay, so for XGBoost, now for all these linear regression and random forest, you need to import the sklearn. For XGBoost, you need to directly install the XGBoost. So you have to write like this. Okay, like this. Pip install XGBoost. So if you run this command, so in mine case, it is already installed. Okay, I have already installed it. So obviously I use it because of that. So you can see your requirement already satisfied. In your case, it might have, if you have not done, if you have not installed yet, so it will download something and it will be done. So make sure, okay, correctly install it, and then just simple from XGBoost import uh, XGB regressor. Okay, so would be the spelling. So make sure that you're writing the correct spelling. Now, what is this XGBoost? Okay, so let me just tell you. This is also one of a model which helps us to predict a value or a class. Okay, if you have to predict something like price, yes, no, some category or risk. Okay, so then this is better than most of the traditional models. Like for like l- it is better than linear regression and some single decision tree. It is better. XGBoost is better. So XGBoost does what? XGBoost basically learns from the mistakes. Okay, so it learns from the mistakes step by step. So basically it builds a small decision tree. Okay, then it checks where it makes errors, then build the next tree to fix those errors, and then it repeated many times, means then again it builds the next tree, and then by fixing the previous errors, then it makes some trees, then fixing the previous error, and this is done. Okay, so that is there. And by combining all the trees, a strong final model is created. Okay, so this is called as gradient boosting. So this XGBoost can be used for regression, it can be used for classification, and for ranking also it can be used. So there are too many parameters which we have to use in XGB regression. One is the N, then we have to set, we can set the learning rate also. What will be the depth of the trees? And at the end, let's set it to 42 only. On the same data, it should also be trained. So XGB dot fit xtrain ytrain. Okay, so again, it hasn't successfully trained. Now we need some modules which will be, we need some functions which should calculate. Okay, based on what we will make the calculations. Okay, so means whatever the till now what we have trained, so based on that we'll evaluate the models. Okay, so now all the three models we are going to evaluate. So what are the evaluations functions which we are going to use? First of all, sklearn dot metrics. Then from here we are going to import first of all uh, mean absolute error. What is this mean absolute error? So this is basically, it is used to average the absolute difference between the predicted value and the actual value. Okay, so for that this is used. Um, then we'll use the mean squared error. This is basically used for uh, to do the average of the squared errors. Okay, to penalize the large mistakes heavily. Okay, so that is the main institution of this particular thing. And then we'll see the R2 score. So now the mean absolute error and the mean square error should be less. So the lower the mean absolute error and mean squared error, the good your model is, and R2 score should be high. Okay. So now what is this R2 score? R2 score is the how well your it tells that how well your model explains the total variance in the data. Okay, so if it is close to 1, so it means the perfect model. If it is close to 0, so means it's not good, no better than predicting. Okay, and if it is negative, so worse than mean prediction. So if it is close to 0, so it is no better than, it is means just predicting the mean. If it is negative, so it means it worse than the mean prediction. Okay, so it makes easy for comparison multiple models. So let me just execute this cell. Okay, we have imported, and numpy we have already imported. So let's just do what? Let's just create a function to evaluate all the metrics. Okay, so evaluate model. So we will write model. So we'll take three parameters: models, x test, and y test. Okay, then we'll create for predictions. Okay, So whatever the model parameter will take, that will predict based on x text. Okay, then we'll calculate the mean absolute error, y text, and y, whatever the predictions is made. Uh, then uh, then we need to calculate the mean squared error. So for that we need to use the square root modules. For that we need the numpy. So sqrt, inside that we will write mean squared error y test y predictions. Okay, then in the end we'll calculate the r2 score. We'll give the y test, we'll give the y predictions. Based on that, it will calculate everything. Now it's not finished. Our function will return these three values. Okay. Okay. Now that's it. Let's execute the function and let's now call the function. Okay. So let's first of all call it for the logistic regression. So LRMEE, because it's running three value, so we'll store it in three value. Okay. LR R2 equals to evaluate model LR, then X test, and then Y test. And now I'll do what? Everything will be same. I'll just change the name. Okay. So here for the random forest, I'll make it RF, RF, RF. Here also RF. The next text and Y test that will be same. Then again I'll change it for XGB, 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 and here also XGB. And that's it. Let's call these three. Okay. Now we can create a data frame to store this results. Okay. So let's just create a data frame first. Then let's calculate the MAE. So here we'll write LR MAE, and the next will be RF MAE, then will be the XGB MAE. Okay. Then we'll calculate then we'll fetch the RMS SC. So again we'll do for LR RMSE, R mean squared error, and then for XGB RMSE, and the last one the R2 score. That's it. Let's print the result, guys. Let's see. So this is the value which we are getting. Okay, for linear regression, the MAE is 24, RMSE is the mean squared value is 28, and R2 score is 0.53. For XGBoost, for random forest, it is 17, RMC is 24, R2 score is 0.67. Okay, for XGBoost, it is MAE is 38, RMC is 47, R2 score is minus 0.259940. Okay, so clearly it is visible here, as we can see it over here, that the random forest here is, that's what I have told you, that the MAE means the mean, what do you say, the mean absolute error, that should be lower, okay, for the model. Then the mean squared error also, it should be lower, and the R2 score should be high. So random forest is the model out of these three models, okay, which are performed very well, okay, which is in comparison to these other two, linear regression XGBoost, the random forest has performed well, means the absolute error is 17, okay, which is higher in comparison to linear regression XGBoost. In those two, it is higher. RMC is also lower, okay, and R2 is also high. So with this, uh, we can say that the random forest is the best, okay. So this wins on all the three matrices, okay. So now what we can do, now we can make the predictions, okay. So for the predictions, we can just simply create a function and just we can make the predictions, okay, that we can do. So let's just try to do that. So for that, we need to create a function. So def predict price using the random forest model. Here it will based on what parameters? So based on location, based on area type, based on availability, based on total square feet, how many bathrooms, and PHK. So based, these will be the factors based on what we are going to do. We are going to predict the house price using the trained model, random forest model. Okay. So all the inputs which we will give, means in which were taken as a parameter, should match the training time processing logic. Okay. So that should be matched. Now let's do what? Let's first initialize the empty input vectors. Okay. So we'll do what? We'll take x np dot zeros and we'll give the total length of. Now before that, what we need to do, we need to have a total count of the feature columns. Okay, so for that, feature columns equals to x dot columns. Okay, because after removing the targeted variable, so we have a different count, so we want to do that. Okay, data frame object has no object x columns, only columns, yeah. And here will store that count so that that many np zeros will be created to initialize with that. So feature columns, okay, Then what we'll do, we'll take the numerical ones first. So X feature columns get location of the total square feet where it is, and equals to, it should be whatever the variable we are going to give, that is total square feet. Okay, and the same thing we'll do it for all the numerical features. Okay, so just like for bath, for bhk, and for ability, we are going to do the same thing. So I'll just copy it. Okay, how many times? More, 3 times, so total 4 numerical columns. Okay, so here for bath, then bhk, ability, ability. Okay, then this was for all the numerical. Okay, let me just put a column over here. Now for the area type, so if area call will be in feature columns, okay, so then do what? Then basically get the location of that particular column, okay, if it is equal to 1. Okay, so make it 1, otherwise. So this is for the area type. Now for the location we have to do it. So basically what we are doing here, guys, we are basically uh filling a fixed, just like how there is a government form. Okay, so this function which we are creating here, we have already created everything in numerical form. Okay, so this function convert the user centered house details into numbers. Okay, and then it will match the training format, the format in which we have trained the models. Okay, and then it will use the random forest model to predict the house price. That what we want trying to do in this model. Okay, and why we have to write this kind of things, because we have already converted into numerical, so we are trying to keep it like that only. So because of that, these things we need to do it. Okay, for the predictions to be done. So feature columns dot get location. Okay, get location of these columns where they are, again make it 1. Okay, and then we'll try to make the predictions. So for the predictions, predicted price equals to, and here we'll make the prediction using the random forest model. Rf dot predict what? The price. Okay, and fetch the first value, and let's return the round off value of this predicted price to 2. Okay, so round off value to till 2. Let's execute the function. Let's see if it is successfully executes. Yeah. Now let's just call the function. Okay. So now uh, what we'll do, we'll call the function. Let's fill the parameters. So let's first start with location. So one location which was very white field. Next was the area type. So there was one location which was something like that, super built up area, if you guys remember, and availability, and more 3 to go. Total square feet will be 1200. Let's give a minimal value 1200. Okay, bath equals to, so 1200 is basically 2, and how many BHK? So 2 BHK. Okay, what type of error? Okay, spelling mistake, that is common with me. So you can see the total price. Okay, 14.68 based on that. Okay, so this is what it has predicted. Okay, so you can change the value, means you can change it to 15 square feet, so value is getting increased. Okay, if we'll change the area, if we'll change the location, so based on that our model has been trained, so it will do the predictions accurately. Okay, so yeah, this is how it is done. Okay, if you want to check for multiple means multiple locations at the same time, okay, and for, based on multiple values, so you can do that also. So what you have to do, first of all, you need to create a list, and you have to create a list of tuples. Okay, first of all you need to do that. So let's just first fill the values. So let's say uh first one is white field. Let's give some random values. Okay, then super built up. Okay, remember the spelling should be correct. Okay, then it will give you an error if it will be not. As you can see, I'm facing that thing. 1200 to 2. Okay, if you want to predict for multiple values at the same time, so you can do that. Yes, it is possible. It is a normal concept of the Python. Okay, let's say in the electronic city there is one area called as the electronic city, built up area, ability 0, 1000 square feet, 2 bathroom, 2 BHK. If you want to add one more, let's add one more. Let's say Indiranagar, plot area. Okay, that's it. Close the list. So now these are the samples. Now we need to call the samples with the function. So for that you can use a loop. So for s in samples, because at the end it is a list, only list of tuples. What we want the price. So call the function predict price rf. Okay, give the values, then print it nicely. Use f string for that. Using f string, first of all print the name based on the area. Okay, location. Then do what? Then give rupees, then give the price lakhs. Okay, let's just print it. So for Whitefield, the rupees will be 14.68 lakhs. For Electronic City, the rupees is 15.64 lakhs. For Indiranagar, the rupees is 16.26 lakhs based on this value. Okay. So this is how you can check for predict for multiple values at the same time, or if you want to do it for single, so you can just simply create a function and use it all the time. Okay. So that is one of the good thing which you have done. So till now, what we have done? So we have seen how to, based on a data set, uh, we have performed the house prediction analysis, in which first of all we started with uh, understanding the data set, then data cleaning, then we performed some EDA, okay, where we have visualized the data based on our best of our understanding. Then we have used three models, okay. First, we have split the data from the targeted variable, so perform feature engineering, and then we have used three models: linear regression, XGBoost regressor, and random forest regressor, okay, to see which one is the best. So based on what metrics? Absolute error, mean absolute error, mean squared error, and R2 score. We just evaluated it using these three metrics, and we get to know that random forest is one of the best, okay, best models, okay, till now. As you can see, and the MAE and the RMMC is low in comparison to the linear regression and XGBoost of random forest, and R2 score is also high. So random forest was the best performed here. Then we created a function to calculate and take the inputs, okay, and then we just call the function to check the function. So if you are a beginner or an entry level programmer, so this could be one of the things which you can put on your resume or put on GitHub, so that uh, means it will be best, and it is totally industry based, okay, house prediction analysis. So yeah, I hope you understood what we have done till now, okay. So by this we have come to the end of the class, end of the live session. Very good, sir, thank you so much. Oh, it's fine, it's fine, okay. I feel pleasure when you guys give messages like this, okay. So that's the thing. So today we have performed the house prediction analysis, okay, and it is totally completed. And as you have seen, I'll share the data set, and I'll share you the this Jupyter Notebook file also. So you guys can go and download it if you want to learn, okay. So you can go and download it from there. It is very simple. So that's it. Let's keep this much only for this class. Thank you so much to make this live session engaging by replying, okay. And we'll see you in the next live session. Till then, have a nice day. Take care. Learn Python.